Hey everyone, welcome back to Code Rash with Gaurav. If you're into AI, LLMs, or the future of intelligent agents, this one's for you. Today, we're diving into Model Context Protocol, or MCP, what it is, why it matters, and how it's the next big leap in the world of AI agents. So, grab a coffee, and let's decode the evolution from language models to autonomous agents, and how MCP ties it all together. We'll explore how LLMs led to AI agents, why context is a mess right now, and how MCP is trying to fix it all. By the end of this video, you'll understand why MCP might be the TCP IP for intelligent agents. Let's start with a simple question. How did we even get here? At first, LLMs like GPT-2 or GPT-3 were just text in, text out. You'd ask a question, and you'd get a smart-sounding answer. Basic prompting. Explain black holes like I'm 5. You'd get a fun, one-shot reply. No memory, no tools, no long-term reasoning. But then came the idea of agents. These are LLMs wrapped with logic to pursue goals, not just answer questions. Example, travel planning agent. You ask, plan a weekend in Tokyo. The agent doesn't just reply. It searches flights, books hotels, suggests places, even builds a daily itinerary. This requires the model to remember tasks, call APIs, use tools like calendars or weather apps, all while keeping the goal in mind. That's a huge leap from a chatbot. And that's where things start to get messy. Agents are powerful, but they depend on passing the right context to the model. And the more capable your agent gets, the more complex that context becomes. Imagine your agent is helping a developer debug code, accessing previous user questions, using APIs like GitHub, Jira, Stack Overflow, storing memory like user prefers dark mode and uses VS Code. All of that is context. But here's the problem. There's no standard way to format it. Every framework does it differently. AutoGPT passes goals, memory, tools in its own JSON format. LangChain uses chains and agents with different schemas. OpenAI Assistant API expects a different structure entirely. This makes it hard to switch models, hard to share tools, and nearly impossible to collaborate across agent systems. In short, no shared language is equal to no interoperability. Enter MCP, Model Context Protocol. MCP is an open protocol that defines how to represent an agent's context, identity, goals, tools, memory, history, all in a clean, standardized format. Think of it as a universal language that lets any LLM-based agent describe itself in a way any other tool or model can understand. MCP doesn't dictate how the model solves problems. It just ensures everyone's speaking the same protocol when describing the problem. MCP is short for the Model Context Protocol, an open standard released by Anthropic in late 2024. You can think of MCP as the USB-C of AI integrations that lets the large language models powering tools like Claude or ChatGPT communicate with external data sources and tools, Obsidian, Gmail, Google Calendar, without needing a million custom integrations. Alright, if you stuck around this far, here's where things get really interesting. Let's talk about the MCP architecture, how it's actually implemented, what an MCP host or server is, and how everything fits together. The Model Context Protocol, MCP, follows a client-server architecture where AI-powered applications, hosts, connect to MCP servers to access external tools, data, and context. Hosts utilize MCP clients to interact with servers, enabling AI models to leverage external resources in a structured, safe, and stateful way. The MCP architecture consists of three main components: the MCP host, the MCP client, often integrated within the host, and the MCP servers. The MCP host is the application using the AI agent, example, a chat app. The client initiates requests, and the server provides access to the required data and tools. They communicate using the MCP protocol. MCP hosts. These are AI-powered applications, such as AI chat apps, code editors, that want to leverage external data and tools for their AI models. MCP clients. These are components within the host application that manage connections to MCP servers and retrieve data. MCP servers. These are programs that expose capabilities like data resources, tools, and prompts to guide interactions. They can connect to local resources like files and databases or remote resources like APIs and cloud services. Imagine a chat application where you ask, "What's the weather in London?" The MCP host, the chat app, identifies available weather tools from its connected MCP servers. It sends your question, along with the available tools, to an LLM. The LLM determines that a weather API tool is required. The MCP host then calls the relevant MCP server to use the weather API, retrieves the weather data for London, sends it back to the LLM, which generates the final answer for you in the chat application. MCP addresses the M cross N connection and integration problem. This architecture gives us decoupling. The host handles logic, the model handles language. You can now swap out GPT for Claude, Mistral, or Llama as long as they understand MCP formatted input. Example: let's say your agent is managing tasks for a project. It calls a tool to check Jira tickets. It calls another tool to write a summary. All of this is orchestrated by the host, not the model. With MCP, your host knows what happened, why it happened, and what to do next. That's what turns a model into an agent. To sum it all up, the MCP host is the brain behind the scenes. It builds context, orchestrates logic, manages memory, and coordinates the agent's journey. If you're building agents or tools, keep this in mind. You're not just writing prompts anymore, you're designing systems. MCP gives you the protocol and structure to do that right. I genuinely think MCP is going to change how we use AI. You could build your own assistant that scans your GitHub commits to catch bugs before you do, or one that reads your calendar and reminds your team about a deadline. You could even have it pull live stock prices and warn you to sell or buy. We're only at the beginning, but it's already inspired a wave of amazing new AI projects, and I can't wait to see what people end up building next. One of the biggest signs that the MCP hype isn't going to die down anytime soon is the growing number of tools that already support it and the ones adding support every day. These tools act as clients. They use MCP to orchestrate agents, call tools, and pass along real-time context. Microsoft Copilot Studio, Claude Desktop, Cursor, Zed, GitHub Copilot. These are some popular MCP clients that are already on board to MCP protocol. MCP servers are the other half of the equation. These platforms expose a model context, protocol-compatible API, so tools like Cursor or Claude can connect, fetch data, and perform real actions. Here are a few MCP servers that you should check out. Appright, Playwright MCP server, Baidu Map MCP server, Perplexity Ask MCP server. Plus, there are tons of other MCP servers out there. Everything from search to storage to stuff you probably didn't even know you needed. If you're looking for something specific, check out mcp.so or mcpmarket.com to see what's out there. I'll be covering how to build an MCP host from scratch in an upcoming video, so make sure you're subscribed.